Welcome to All About Mars Surface, where every ridge tells a secret and every stone hides an untold story from billions of years ago. But today's image is not just another Mars photo. Look closely. Those aren't ordinary rocks. They are witnesses of cosmic violence, ancient energy, and strange geological codes still active beneath the Martian crust. In this image, the landscape appears calm, silent, almost lifeless. But geologists now believe this region might be a geological memory zone, where each rock preserves energy traces from ancient Martian eruptions. Notice the round-shaped stones. They didn't form randomly. They are shaped by billions of years of erosion under a thin atmosphere. Their surfaces smoothed not by water, but by electrostatic winds, tiny charged dust particles, slowly sculpting them into spherical perfection. Scientists observing similar formations call it the magnetic ridge zone. Some rocks here seem to contain high concentrations of iron oxide and magnetite, creating faint electromagnetic signatures even detectable from orbit. It's almost like this region was once a giant magnetic field lab, where the Martian crust cooled and locked magnetic fingerprints of its fiery youth. Each stone may hold a tiny magnetic direction, together forming a map of Mars' lost magnetic poles. See that layered hill in the distance? That's not just sand and dust. Those are volcanic ash layers, frozen in time. When ancient volcanoes erupted millions of years ago, lava mixed with dust, solidified and cracked, forming rock sheets like we see here. Each line is like a page in Mars' geological diary, recording eruptions, impacts, and cosmic storms. Some of the rocks at the front, you can see, appear to have bubbled textures. Those might be lava stones, once molten, now cooled into strange, porous structures. Now look at the lower center region. Some rocks look unusually carved, as if shaped by intelligent design. But scientists explain this as fracture geometry caused by rapid heating and cooling. However, what's fascinating is the consistency. Many of these rocks have almost identical angular cuts. This could mean a specific mineral alignment, or perhaps the result of ancient meteor impacts that fractured the surface symmetrically. Some researchers even call it nature's Martian sculpture park. Every stone, a frozen sculpture of time, energy, and pressure. On Earth, wind carves canyons, but on Mars, dust storms carve entire histories. Because the air is so thin, it doesn't carry water, it carries electricity. These charged dust particles may actually etch patterns on rocks, creating microburns, fusion marks, and erosion lines, like nature's own plasma cutter. That's why some of these rocks look polished and others appear pitted, as if blasted by invisible lasers. When NASA's rovers analyzed similar stones, they detected minerals that form only under high thermal stress, meaning these areas were once superheated by massive energy bursts, possibly from subsurface magma vents or meteor shocks. So what we see now isn't just Mars present. It's frozen fire, the solid remains of Mars' once active inner life. If these rocks truly carry magnetic memory, then decoding them could reveal the direction Mars' poles once faced, the intensity of its magnetic shield, and maybe even how it lost it. It's like holding a piece of a cosmic puzzle. Each rock, a data chip containing secrets of an entire planet's evolution. Look at those darker patches between the ridges. Those could be collapsed vents or ancient fissures, where heat once escaped from below. Some recent analyses suggest these areas still emit infrared traces, meaning there could be residual geothermal activity deep underground. Mars may look dead, but it might just be sleeping, its inner heart still pulsing quietly beneath a blanket of dust. Stones that once kept silent are finally speaking. No rivers, no oceans, only rock, impacts and magnetic memories. Fragments of an ancient world written into stone. Today we listen to what Mars's rocks reveal, and I promise you things you haven't heard before. Stay with me. Mars no longer has an active global magnetic field, yet its crust stores a powerful message: remnant magnetization. In other words, ancient rocks froze a magnetic fingerprint when Mars's internal dynamo was still alive. These magnetic patches are windows into the planet's earliest engine, telling us when the dynamo ran, where crustal stress is concentrated, and which regions once experienced organized tectonic forces. Unlike Earth's constantly recycled crust, parts of Mars's crust have preserved those magnetic signatures virtually unchanged for billions of years. That preservation lets us map ancient fault zones, dike swarms, and episodes of crustal heating. In some regions, the magnetization forms linear patterns, likely following ancient fractures or volcanic intrusions, a kind of fossilized roadmap of early planetary processes. When meteors strike at high velocity, intense heat and pressure can melt rock and quench it into glass. Mars hosts widespread impact glass, shards formed instantly inside crater-forming events. This glass is not just shiny debris. It is a time capsule. Impact glass captures rapid chemical and structural states at the instant of impact, cooling rates, shock pressures, and microstructures that survive for eons. Those microstructures can reveal the angle and intensity of ancient impacts, the original mineralogy of the target rock, even transient high-temperature phases that vanish from ordinary rock. In short, impact glass preserves a freeze frame of catastrophic events, and reading it gives us a direct record of Mars's violent past. Mars still moves. Recent global surveys catalog thousands of rockfall sites across the planet. These are not relics from billions of years ago only. Many rockfalls are modern, triggered by thermal cracking, seismic jolts from distant impacts, or sudden collapses along steep slopes. Mass wasting on Mars operates without liquid water. Dry avalanches, block slides, and collapses reshape slopes slowly but continuously. The size, density, and distribution of these rockfalls tell us how stresses are distributed across the crust today, and how fragile cliff faces respond to the planet's cold, thin environment. Each new rockfall is a live signal. Mars' surface is still being sculpted by mechanical forces. Rovers have photographed strange, small spheres and banded, striped rocks. These features are not random decorations. They record specific formation processes. Small spherules often form where a melt or vapor phase cooled extremely quickly, trapping bubbles or creating concentric growth textures. Striped rocks, alternating dark and light layers, suggest rapid changes during formation, pulses of heat, flows of different composition, or rapid redeposition during energetic events. Some of these stones are float rocks, moved from their origin by impacts or mass wasting. That means a single rock can carry a history from a different environment to a new one, acting like a sample courier. Interpreting at Mars rocks are not just rubble. They are records, magnetic archives, impact time capsules, and active testaments to mechanical change. We avoided talking about water today on purpose, to listen instead to what the dry processes tell us. If something in this video surprised you, like it, and subscribe for the next episode where we'll open rover-level lab analyses and extract microscopic stories hidden inside those rocks. Until then, keep listening. The stones are still talking. Thank you for watching till the end. You were watching All About Mars Surface.